I've come to today to talk a little bit about data mesh. I feel like you're a long way away, by the way. So I've come to talk about data mesh. Data mesh is interesting, and there's a lot of interest in the UK, in France, in Germany, smaller in the US. But data mesh isn't really about technology, and it's not really about Starburst. So I'm going to talk about data mesh. If you want, we can talk a bit about Starburst. But I don't want to make this a session where I say, Starburst is amazing and you should buy it. It is, and you should, but that's not what we're going to talk about. We're going to talk about data mesh. And I've put I'll introduce myself in a moment, but just to let you know, I've put 3 links up here. So we've got, these are PDFs that you can download for free from the Starburst website. The top one is a very short book, Data Mesh for Dummies. I am an author of this book. It's probably if you want to understand a bit more about data mesh and you have little time, that's probably the best book to go to. The second one is a book written by a guy that I know very well. It's a company called Zalando. They're an online fashion retailer in Germany. They have implemented a data mesh, and he talks about some of the problems, some of the things that they saw. And then the last book is the official book by a lady called Zhamak Dehghani, who wrote and came up with the original concept of data mesh, and I'll talk a little bit about this. That's about 300 pages, and if you've got a lot of time, it's a good book, but it's a lot of time. And then there's my QR code if you want to connect to me on LinkedIn. So so you can see these things. So in terms of an introduction, my name's Andy Mott. I come from Starburst. And my day job is that I work with cool people like Emre and the other folks at Comtash, with the partners across all of Europe, to help them understand some of the technology aspects of Starburst. That's my day job. And then in the evenings and at the weekends, I spend my time reading and writing about data mesh and arguing with people about data mesh and presenting about data mesh. And therefore, I'm a really fun guy because that's how I spend my spare time. So we're gonna focus on data mesh today. When I present on this, I typically have very large audiences. And so there's a real interest in data mesh across Europe. And we'll come on to why that is in a moment. So I've only got an hour, and normally I spend about 3 or 4 hours talking about data mesh when people let me go. So I will try and be quick, but also if you have any questions, please ask. And if I talk too fast, please tell me. Sometimes I get excited. So the concept of data mesh, this is a one-line definition by this lady, Zhamak Dehghani. She wrote an article in 2019 on a website called martinfowler.com. Martin Fowler is like a father of kind of programming, object orientation, UML modeling languages. He's been around for a very long time, and he's very respected. Zhamak wrote this article, 2019, it got a lot of interest, and this is how she defines data mesh in one sentence. I guess the key point is this socio-technical. Basically, we need to think about people and organization and process more than we have in the past. This is a good definition. I have a different definition. So my definition is the decentralization of ingesting, transforming, and serving data. And we'll come on the next slide to unpack what that means. But decentralizing, getting the data from different places, transforming it in the way we need it, and then giving it to people for whatever need they have. So let me come to this slide. So I'm assuming everyone in this room has some knowledge of the picture that I've got up here. On your left-hand side, Sol, we've got operational data systems. We have systems that collect data about our business. So whether that's website data, whether that's energy usage, whether it's mobile phone data, the way people interact with our products. Maybe it's customer journey through a website, for example. And we capture that information because that's useful for the applications. And then on the other side, we have the analytical data plane. And the analytical data plane is where we collect this information together and we build warehouses and data lakes. And we do analysis to understand what people have done, how maybe the energy's been used, how people have reacted to a drug, how people are using our services. And then we might use that data to make a better decision and maybe change the operational systems. And then in the middle, we have ETL, ELT, data pipelines, data movement, whatever we want to call it. And that's really the pattern that people have adopted for 20 or 30 years. And if we think about problems with this, and I'm sure these are problems that you will experience, we have people who will say, I would like new data over on the analytical plane. I would like new data, and I would like to make get this other data and join it and make some better decision. And the reality is that they will call someone, or they will email someone, or there'll be some process where they talk to the people in the middle, the ETL team, let's call them, the data team, and say, can I have this data? And the data team will say yes, and they will raise a ticket, and they will put it in their system, and at some point later, they will look at the ticket, and they will do the work, and then they will phone up the business person or the analyst and say, here's your data. And the business person or the analyst will say, don't care, because the world has moved on, you've taken a month or a week or too long, and now I've got other things that I'm going to focus on. And I assume that's something that you are familiar with, this kind of delay in getting access to data that we need. And then on the right-hand side, on the operational data plane, we have this other problem, which is data isn't really the first concern of people who run systems. People who run systems are worried about the website crashing, right? That's what they're focused on. They're worried about not collecting data. So it may be that they can make a very simple change on the operational data plane, which has a really significant impact somewhere else. So a simple example might be if we had a website, it might be really easy in the website application to switch on maybe mouse tracking. So we can see how the mouse moves or the pointer moves on the screen. And we can collect that information. And that might be then really interesting when we're on the analytical plane to be able to understand how people are kind of viewing and how they're interacting with the screen without necessarily clicking on things. But if I'm on the operational data plane side, I have no motivation to turn that on. So I won't, because it doesn't help me run my business. It doesn't help me run the systems. So therefore, we've kind of got two missed opportunities. One is the business people, the analysts who want the data cannot react fast enough because they can't get access to the data. And then on the operational data plane, we have, I think, a worse problem, which is that there is new and interesting data that we probably don't capture because those people don't care, because that's not their job. And that's fine. I'm not blaming them. It's not their job to worry about data. And then we have this piece in the middle, this ETL guys, who I think central data teams have the worst job in kind of the data and technology space. And the reason I say that is because if you think about how much they need to know in this picture, they need to understand all of those systems on the operational data plane, how to connect to them, how to get data. They need to understand the data in the operational data plane, the data models, what the data means. They need to understand how to get that data and transform it. And when we transform data based on business rules and kind of context. What a customer looks like in a logistics system may be different from what a customer looks like in a marketing system. So they need to know all of that. And obviously the technology that they're using to do that transformation. And then on the analytical plane, they need to understand the technology they're putting the data into, whether that's like a cloud data warehouse or an on-premise warehouse or a lake or Hadoop or whatever it is. And then they also need to understand the data model in that warehouse or data lake to be able to put that data in. And that's a lot. And this is why traditionally when someone needs new data, they phone someone up and they get the data a long time in the future. And businesses can't wait that long. So there's lots of problems, but this is what we've been doing for a long time. And so this is kind of why there is a motivation to do something different. Now, we can argue if data mesh is good or bad, but I think we can all agree that what we've got and what we've been doing for 20 or 30 years is not the best. There's better ways that we should think more about how we do things. And you will hear people say, oh, you know, we can put it all in a cloud data warehouse, like Snowflake, for example, or you know, we can use Hadoop, or we can use this other technology, or we've got this concept of the modern data stack, which is, you know, DBT and Airflow and you know, data catalogs and all that stuff. Fundamentally, they are not necessarily solving this problem, right? It's just this problem, but new and shiny. So data mesh is kind of saying, well, let's have a different approach to this problem. So these are some of the issues, and for the purposes of time, I'm going to skip over this slide. That's just a summary of what I've said. So the objective of data mesh, in one sentence, the objective is really for organizations to be able to be agile when we're talking about data. So when someone in the business says, I would like to get some new data, they can get new data. When someone says, I've got a problem with this data, they know exactly who it is to phone up, exactly who's responsible. When someone says, I've got a report that says 5, and someone else has got a report that says 7, we can very quickly identify why one says 5 and why one says 7. We can do that very quickly. And the idea of data mesh is to provide an organizational technology structure that enables us to do that over a long period of time. So that, you know, if you read the McKinsey's and the Harvard Business Reviews and all of these, you know, big-brained people, they will tell you that, you know, data is a weapon and analytics is a weapon, and this is how you outcompete each other and all that good stuff. And so really, data mesh kind of fits into that idea that by being able to respond more quickly with data to challenges, you know, maybe our competitors are doing something new, maybe the regulator has changed the rules, maybe we have bought a company and we need to get that data into our systems, or whatever it is, that we can do all of those things, or we can respond to those things when they happen. That's really what the objective of data mesh is. So I'll talk about this and then I'll stop for kind of questions. So data mesh is basically comprised of 4 principles, and I'm going to talk a little bit more about these on the next slides for basically the rest of the presentation, because when you first see them you think, well, that could be quite easy, but then when you start thinking about them a bit more, you think, oh, actually, you know, there's some things that we need to kind of consider and think about. And data mesh, I should say, is not for everyone. I will say this. Actually, before I get on to what's on the slide, I'll talk a little bit about that. So if you have an organization where the data you have doesn't change, you know, you don't have new sources of data, you don't have changes in your source systems, if your end users are happy with what they've got and never ask for anything new or different, and if your central data team, you know, can respond very quickly to whatever they need to respond to, then I would suggest that don't worry about data mesh. Just keep using a data warehouse, keep putting everything in a lake. If you have new sources or changing sources, if you have people who ask for new and different data to do new and different things, if you have a central data team that sort of complains that they don't have enough time or can't respond, then data mesh is worth considering. So, because I get asked that often, how do we decide whether we should think about data mesh? So these 4 principles. So domain ownership is this concept of, instead of having one central data team that's responsible for all of the data from our source systems to our analytics systems, let's split that up and let's say, actually, the marketing team, for example, they know marketing data best. They know, let's say, website traffic data better than everyone else. Let's make them responsible, give them ownership for that data. Now, that's cool, and that has some implications, which we'll talk about. But once we've given them responsibility for that data, they also need to be accountable for making that data available to the rest of the organization. And that's where we start thinking about data products, or data as a product. And I will talk in more detail about what data products are. They're not just a simple table. But so now we have maybe the marketing team who are responsible for this, let's say, website data. They need to package up that data in a way that's useful for the rest of the organization. And that's really what this data product thing is all about. Now, I would argue that is really all data mesh is. It's those first two. The problem is to let the people in the domains, people in marketing, for example, do the work they need to do, so access all the data, transform it in a way that's useful, and then make that, that website data available as a product. They need to have some technology, and that's where we get into this self-serve data infrastructure. So people talk about self-service, and I hear self-service BI a lot. This isn't that. This is the ability to go, I would like to ingest some data from this place. I would like to transform this data, and I would like to make this data available. But I don't necessarily need to know about the technology, because I don't care about the technology. What I'm actually caring about is the data, the quality of the data, the latency of the data, the structure of the data, the usefulness and the valuable, the valuableness, it's not really a word, but the value, I should say, of the data. And so they need some form of technology which allows them to do this without being technologists. And that's really what self-service data infrastructure is. And then the last one is federated computational governance. And every time I present this, I say that you will see lots of people talking about data mesh who will talk about federated governance. And they miss out the computational bit because computational is hard in this definition. So the federated computational governance is really, the federated bit is we get the domain owners together to make up some rules. So how do we deal with address data, for example? It may be that for a large percentage of the usage, so for most use of the data in an organization, we want to not make address data available because it's personal information. Right, so that might be a rule that the people who are owning the domains, and I'll describe what a domain is in a moment, but those people who are owning the domains are responsible for making that rule. The people in the domains are now responsible for implementing that rule. So it might be that we want to hash the address, or it might be that we want to just drop the column, or null the column, or somehow hide that data. But then the computational piece is that the self-service platform will automatically determine whether that has been done. So, this is where we start getting into things like automated testing of data. So maybe we have a little process, a little unit test that says, if the column has data that looks like address data, and that is available to people, then we're not going to allow that data product to be available to people. And that's the computational piece is really that automation. And this is basically what data mesh is. It's these four principles. And what I'm going to do is to say, I'll go into a bit more detail about each of these, but I'm going to pause for kind of questions. Does this make sense? Am I speaking too fast or too slowly? All good? Okay, any questions? No. Right. Okay, so domains. So when I first started talking about data mesh, and I still do actually, I do regular chief data officer events in the UK and in Germany, where we get chief data officers kind of round a table of big companies, and nothing is recorded and it's all said in secret, so I can't reveal names. But the first question I used to get from chief data officers was, how do we define a domain? And it's interesting because they've moved on now. And now it's all, the questions we get and the things we talk about is all around data governance, but originally it was domains. And what I've seen in America is very strange. What I've seen in Europe is not strange. So in Europe, what people have done is they've said, we will have a domain, and a domain is really just a collection of people. We will have a domain which maps to our business units. So if we have a marketing department, let's call that a domain. Let's make the head of marketing the domain owner. The same for logistics, the same for operations, the same for finance. And so we see this kind of one-to-one mapping between a business unit and a domain. In America, they've done something very strange, which is kind of they've gone the other way, which is they've got a domain for customer. And when you think about that, that's quite hard because customer could be owned by marketing, could be owned by finance, could be owned by logistics or someone else. And so they kind of look at their business units and then they build domains the other way around. And it gets very complicated, I think. But certainly in Europe, we see this mapping of we've got a business function. Let's just call it a domain if we're thinking about it in a context of data mesh. Now, I talked about this central data team, and I talked about the fact that they have a hard job. And I mentioned about this decentralization. So if we think about what that means, and I'm always conscious when I say this because oftentimes I'm talking to people who are in charge of data teams. But the reality is, what data mesh kind of suggests is that actually a lot of the people who are responsible for data in the data team will in some way, shape or form be aligned to those domains. So it may be that we don't have a central data team. I'm not suggesting you don't have one, but let's just take that example. So maybe we don't have a data team anymore, a central data team, but those data engineers, data scientists, architects, data modelers, all those skills, all those roles basically become part of the domains. So we may have data architects or we may have data engineers who live in marketing. Or in my case, I've got 4 domains. So this is for our website. So I've got merchant data, bestseller data, user data, marketing data. So we can see that central data team, essentially, those people become part of the domains. There's lots of different models. We don't really have time to go into all of them, but to give you some examples, I have seen people just get rid of their central data team completely. I've seen people have central data teams where the data engineers and data scientists, all those people, still work in the central data team, but are kind of seconded or aligned to the business units. So they still have a central data team, but the people actually just work in the business units. I've also seen an interesting approach where the data people, and let's just call them that for the sake of argument, the data people move domains every 6 months, and they kind of rotate around. And there's pros and cons to all of these. But what we're essentially saying is we no longer have this bottleneck. If there is someone in marketing who wants access to some new data, they have someone in their team who can help them get that data. They don't have to wait for a central data team. They can make their own priorities. If they have someone, if they have a data engineer who's working on project A for marketing and they actually need project B to be higher priority, the marketing department, the domain owner, the head of marketing, can make that decision themselves. They don't have to rely on someone else. So this is kind of one of the first interesting concepts. I mentioned about that socio-technical. This is very much about people and process. I talked about this idea that domains are responsible for data products. And so when we think about a data product, what we're kind of thinking about is essentially a piece of code. And again, I'll come onto this in a bit more detail. But what we want our domains to be really focused on is that piece of code which is doing some data processing. We want them to focus on that. We don't want them to focus on technology. And when we think about historically, we've had people like an Oracle DBA, for example. I'm not picking on Oracle, but they were always the guys in the corner who you went to if you had a data modeling thing, or if you wanted to optimize the queries, or you needed to optimize the infrastructure. That doesn't really exist in a data mesh because they're 2 different roles. There is someone who's responsible for the data and someone who's responsible for the technology, and they are different people in different teams. So the people who are domains are really responsible for this data product. Now, I would suggest that really we want to focus on kind of known technologies. So things like SQL. SQL is a very well-known technology, and therefore it's a good language to kind of consider as kind of your language of choice. Other people will say things like Python and Java and Spark, but I just don't think there's that many people out there that have those skills. But I think there's a lot of kind of SQL out there. And this then gets onto the next piece around domains, which is quite interesting, which is where it might be that you say, actually, we don't have that many data engineers, right? Well, that's to be expected. If we're using a relatively common language, or we're using tools that allow us to build things with no code or low code, then maybe we can get some of the analysts who are in marketing to work with the data engineers in marketing to kind of spread those skills and get other people in the domains to be able to be more data literate. I think data literacy becomes important as well. It's not really talked about in the context of data mesh, but data literacy will increase either before you adopt a data mesh or as you, in your data mesh journey. And it kind of has to, because otherwise the people can't do the things that you're now asking them to do. And we'll talk about why they might want to do those things in a moment. Now, there's a lot, this slide I like talking about, there's a lot on this slide, but if we think about that example that I had where we have these 4 domains, we've got merchants, users, marketing, and bestsellers, we can kind of see that over on this side, we've got this merchants domain. I don't know if I've got a pointer. Have I got a pointer? No, yeah, it's this one. No, anyway, so they produce a data product, which is basically a list of top-selling products, right? It could be very simple. That is then being consumed by marketing. And then marketing will create a data product, and that data product will be used by someone else. And actually, this is where the term mesh comes from. It is the connections between the different domains based on data products. So I could create a data product in merchants, and it may be that, let's say, Emre, who's not here, he is in marketing. He uses my data product to create his own data products that are then valuable to other people. And it's that, so my data product becomes a node in the mesh, and the fact that Emre is using my data product means that we now have a relationship between my data product and his data product. And those relationships are, if you like, the connections in the data mesh. And this is where the term data mesh comes from. And I say this because I do lots of presentations where I have seen other vendors talk about data mesh as something you buy or whatever. But really, this is what it is. It's this connections between the different domains. And therefore, if we think about that ETL, that data pipeline thing that I talked about before, between the operational and the analytical planes, that's if we think about that as a set of processes, a set of data transformations that transform the data from our operational system, transform it, and we may have data marts or whatever today that come out of each transformation. At the end, we have some sort of data. If we think about a data product, what we're really thinking about is taking each bit of that data pipeline, each transformation, if you will, each job, or whatever we want to call it, and we're saying, marketing, you should be responsible for that bit. Merchants, you should be responsible for that bit. Users, you should be responsible for that other bit. And essentially what we are doing is taking that pipeline and we're giving responsibility for bits of that pipeline to different people. And so now we're giving kind of ownership. So we don't actually get away from data pipelines. What we are doing is giving ownership for parts of that pipeline to different parts in the organization. Any questions on domains? I'm going to move on to the next topic because I'm conscious time is always pressing. Right, so data and product thinking. So when we think about data products, again, there's lots of debate on this. People will say, oh, Kimball with this concept of data marts, and he thought that was the best approach. So you end up with some tables that have relationships that are focused in a particular area. So you may have like a fact table full of transactions, and off of that you may have a dimension table, which is the customers who were responsible for those transactions, and you may have something off of that like the address table or whatever it is, or off of the off of the customer table. And these things were kind of packaged together as sort of subject areas. And there was another guy called Inman who said, actually, you need to integrate everything together into data warehouse. And that debate has been going on for 30 or 40 years. And often I get people say, oh, well, a data product is just like a Kimball data mart. And I kind of say, well, it kind of is, and it's not. So when we think about a data product, we think about a data product kind of containing data, but it also has other attributes. So when we look down that list on the left-hand side, I won't go through all of them, but we need to be able to find a data product, right? So inherently, we need to have some way of basically going to a system and saying, I'd like to see all of the data products that are related to customer. Get a list of those. Now what I want to do is click on one of those, and I want to see something that says, what's the description of this data product? How many people have used this data product? How many people gave it 3 stars or 5 stars or whatever? What are some typical usages of this data product? Right, so what are typical queries, for example, that run on the data that's part of this data product? I'd like to see who is responsible for this data product in case I want to communicate with them, phone them up, email them to say, oh, I think this data product would be useful for doing this kind of analysis. What do you think? Right? I want to find all that. I want the security to be part of the data product. I'll come on to that in the next slide. So you can start to see that a data product isn't just the data, it's all these other things as well. I need to be able to find it, use it, access it in a secure, governed, controlled way. And so that then makes it more than just a set of tables. And then we get into, there's some terms down here, things like polyglot persistence. Really that just means that actually we might persist this data in different forms as part of that same data product. So it may be that I want to access this data as a stream, or I may want to access this data through a REST API, or through a SQL interface, or from using a machine learning toolset. And that sort of definition is commentary around this is stored as part of that data product. So this is my little kind of I don't know how to say this in Turkish, but this is a thing that makes me slightly angry. I should know that because my wife is often angry at me. So I go to lots of conferences and see lots of people talk about data mesh, and most software companies will say this thing over here is a data product, this kind of definition of a table, and the slide that I've just shown shows why that can't be true. But I've seen all these other definitions as well. So the next is sort of step up, right? So if we say it's more than a table, well, maybe it's a table of metadata, and that's fair. So if we think about what metadata is, metadata in this case is maybe the schema. So it's what are the tables, or the views, or materialized views, what are the columns, how many rows, it's all that table stuff. It might also be the attributes. So it may be that I want to tag my data product as information related to customer. It may be things like the usage examples. So there's quite a lot. Actually, sorry, there's one other thing. It might be security or policies as code. And there's a longer conversation we could have here, but I would like the ability as the person who produces the data to be able to tag my data and say, Emre can access this data, but I don't know, Evrin cannot. Right? I want to be able to do that, and I want to store that as part of my data product, so that when Emre accesses the data product and Evrin accesses the data product, they can find the data product, they can see the data product, they can access it, but actually one gets to see the data and one does not. And that definition is metadata. Right? It's just policies as code, it's just metadata. So then the next one in the middle here is this concept of access patterns, and I kind of mentioned this on the next page, so on the previous slide, where we talk about the way we want to access it, whether it's a stream or whether it's a SQL interface or whatever. And so this definition could be stored as part of the data product itself. Now when we move to here, we introduce code. So we've got all the other things as well. Now what we're saying is actually our data product also consists of the code that is used to generate the data itself. So now I have a data product that I can execute. So I can say I would like to execute this data product every week or every hour or once a night, every night or whatever it is. Right? So now we're introducing this concept of, and this could be SQL or it could be Spark or some other data transformation language that's part of this file, if you will. And then over here, the last thing is infrastructure. And so this is interesting when we start getting into clouds and or even on-premise, but things like Kubernetes, where we can say, I would like to start up some computers, and on those computers I would like to have some form of execution engine, a query engine or whatever it is. Then I would like to run my code on that query engine on those computers. And I'm going to output some data, and I'm going to store that somewhere. This is all defined in that data product. I'm then going to have some attributes, which I'm going to put for that data that I've created into a data catalog. I'm then going to have maybe some policies, some security information, which I'm going to push into a policy management tool. So some sort of form of central security system. So now, and then the last step might be to stop all of this stuff, to turn off those computers that I turned on at the beginning. So what we can think about is this is basically a text file. Right? It's nothing more than that. It's a text file of instructions. And if we think about it as a text file, you know, whether it's JSON or YAML or XML, I wouldn't do XML, but some form of markup language, what that then means is we can then put it into something like GitHub or some sort of version repository. And now we can start getting into some cool stuff, because now we can start thinking about versioning data products. And if we get back to what I said before, when we think about that ETL process, and I have bits of code that are owned by different domains, clearly, if I was to change my data product, let's say I took a column away, I may break all of my downstream users or my consumers of my data products, whether they're just looking at reports or whether they're using my data products for their own, to create their own data products. But once we start getting into versioning, we can start getting around this sorts of problems. So I could create a version 1, which maybe has columns A, B, and C. Emre creates a data product which uses A, B, and C, which uses A, B, and C. Right. Then I say, well, actually, I no longer have C in my source system, so I need to do something about that. So maybe I could make it blank, maybe I could remove it completely, or do something else. But if I remove it, then maybe Emre's code breaks, right? But with versioning, obviously, I can say, I'm going to create a version 2, and I'm going to take away that column. In version 1, that continues to run, right? That continues to build the data sets. Emre continues to consume my data. I now have the flexibility to create version 3, version 4, version 5, version 6. At some point, there's some form of notification that says, Emre, I am going to stop refreshing data product version 1, in 2 months' time, you need to change your code. And now Emre can create a version 2 of his data product, which maybe, then he has other people that use it. And so we get into this kind of cascading versioning approach, which allows us to be flexible to meet our needs, but without breaking everybody else. So in this text file approach, and that's really all it is. People will make it more complicated than that, but this text file approach allows us to get very much closer to that, to that kind of concept of being able to make changes and not break all of our downstream users. So does that kind of make sense? Is anyone kind of looking at me thinking, this guy's an idiot? Is there any kind of questions? You're very quiet. I feel like you're also a very long way away. Is this useful? I mean, at the very least, you can walk out knowing what data mesh is. Whether or not you choose to implement it or think about it anymore, at least when someone else comes and says, oh, you should buy a data mesh, you'll be like, yeah, you can't buy a data mesh. At the very least. So, I've got about 15 minutes, so I'm going to whiz through these. So, self-service infrastructure. So I kind of talked about this a little bit. The idea is that the domains can be able to be self-sufficient without knowing anything about technology. So actually, we end up having a different team, a data infrastructure team, an infrastructure engineering team, whatever we want to call it, people who are responsible for providing technology capabilities don't care about data, and nor should they. They just care about making sure that the systems that are available meet the requirements of the domains. There's some interesting interplays that we've started to see where the merchants may, in this case, let's say the marketing domain may say, actually, we need a streaming capability. So the question is, do they create a streaming capability and then it gets becomes part of the platform, or do they say to the platform team, can you build the streaming capability and then we can use it? How that works, different companies do different things. But essentially, a bunch of capabilities, technology capabilities that the domains can use without being technology experts. This I think is interesting, and I'll just mention this. This is quite low level, but what becomes really interesting when we think about data mesh is interoperability between systems becomes really, really important. And I'll give you an example. Let's say in this picture we have 4 domains across the top. We have 3 technologies, Spark, Starburst, and Kafka. Have to have Starburst, obviously. And then underneath that, I've got a Hive metastore, so metadata repository, security system, and a data catalog. Now, if we think about metadata for a moment, because metadata is an obvious example. If I have a scenario where I have metadata that is useful and available for one of my engines, right, but not others, then that becomes a problem. So let me pick on Snowflake for a moment in an example. So I'll put all my data into Snowflake. In Snowflake, I have a cool metadata repository, right? I can find my data really easily. If my domain says, actually, I want a stream of data, what do I do about metadata, right? I have metadata in Snowflake. I need the metadata to be available for my schema or registry, etc., in Kafka or Confluent or whatever I'm going to use. Or if I'm using something like Databricks, right, for Spark processing. How do I get that metadata from Snowflake to, let's say, Databricks? That's an easy question to answer. The hard question to answer is who's responsible. And the answer in a data mesh is no one. That's the reality, because metadata is a data concern. As soon as it becomes a data concern, it's not the responsibility of your infrastructure team. Right? They have no knowledge of metadata, nor should they. That's not their job. Their job is to provide systems. The people in the domains know a lot about data. They shouldn't know anything about technology. Well, they shouldn't need to know anything about technology. But if you're asking someone in a domain, someone in marketing, to say, actually, we are going to be responsible for synchronizing metadata between Snowflake and Databricks, that's quite like an ask. That's quite a technology thing to ask a marketing function to do. So when I talk about interoperability, what we need to think about is how do we make it so that we have some common platform capabilities that work across different systems. So we see this pattern of things like Spark or Databricks, Kafka, Confluent, Starburst. We see this quite often where they will all use a common Hive metastore. That's kind of why I put it in there. And so let's say Databricks comes along, it runs an ETL process, it puts the data out into, I say, S3 in Delta or Parquet or whatever it is, registers it in a Hive metastore, an external Hive metastore. As soon as that process is complete, people can start querying it with Starburst, because Starburst can use that Hive metastore. And as soon as Spark's finished putting it in there, if we want to access that data as a stream, we can start accessing that through Kafka. So that interoperability requirement becomes really important, because fundamentally, in a data mesh, there is no one who would be responsible for doing things like synchronizing metadata. And if we think about that from just a business point of view, that should be the way the world is anyway. If you're starting to put everything in one platform, that's fine. If you get 100% of everything in one platform, your world is easy. As soon as you have less than 100% of data in a platform, then you need to make sure that platform and all the other platforms are interoperable and easy and zero friction. And that's where common standards. So enterprise security, you might choose something like Immuta or Privacera or even Apache Ranger as a repository for policies that different systems can start to share. So, I'm kind of just conscious of time. So these are some of the things that I've kind of said already. So some of the principles of a platform: self-service, domain autonomy, interoperability, separation of data and infrastructure. These are pretty similar. So simple languages, fine-grained security, so being able to apply fine-grained security. And I'm kind of stepping over that because I've sort of said it, and also time. So federated computational governance. I'm going to spend a little bit of time on this, not too much. So when the original papers were written in 2019, there were only 3 principles. There was not this. Now, what's interesting is without the governance piece, basically if you just get domains, get groups of people to build data products and give them a platform to do it, and you don't have governance, what you basically end up with is what we would say in English is anarchy. I don't know if that translates into Turkey, but basically you have chaos. I don't know if that translates. You have a mess. You have something that can't possibly be useful at all. And that's because if I create a data product and I think about customer in this way, and Emre, I'm picking on Emre a lot, he creates a data product which defines customer in another way. How on earth do I know how to bring these two things together? And so this governance is really about defining those rules that allow me to have interoperability at a data level between data products. But it's interesting, as I say, when the paper came out originally, missed out this. And so I said before, people miss out the word computational. Sometimes they just miss out this completely because, again, because it's hard. So I would say these are some of the really important aspects of governance when we think about data mesh. So things like access controls, obvious, automation I've talked about, data catalogs. So we need some way of kind of registering and finding data. So we need that in when we think about governance. Lineage and provenance. What are the data products? What are the upstream data products? Who are the people that I need to talk to about, about their data products that I'm consuming, and who are the people downstream that are using my data products that may need to contact me? But the important one on here is usage metrics. And the reason this is the important one is because people haven't really considered usage of data as part of governance before. And what I mean by usage metrics is how many people have used your data product. And I work with some companies who already have in place a link between the usage of data and value. So they basically say the more times, the more people who are using a data product, the more valuable a data product is. And then they go one step further and they say, at the end of each month or the end of each quarter, the people who are responsible, let's say in marketing, for creating data products that have a high usage, they get a bonus. They get money, like literally money, which I find quite interesting. So now what we are doing is we are incentivizing people on the value of data, which I think is something quite new, something we should have done years ago, but no one's really done. And so usage metrics, so your platform needs to have this ability, no matter whether you're querying the data through a SQL interface, no matter where the data lives, whether it's through SQL, whether it's through Kafka or Spark or whatever, to be able to capture those usage metrics and basically be able to say, my data product has been used by 1,000 users this month, and therefore I'm going to get a bonus of 10 or whatever it is, 100. Furthermore, what you also want when it comes to usage metrics is what's the first thing people do with my data product. So if I create a data product that 1,000 people use and 800 of them, the first thing they do is they sort my data product. I need to know that as the data producer, because what I will do is then I will maybe make the decision to sort my data product so that they can just use it without having to sort it. Or maybe I'll create another data product. Or maybe I'll create a new version or something else, but I will have the information to make that decision. And the reason I want to do this is because the easier I make my data product to use, more people will use it. The more people will use it, the higher the value to the company, the more money I get in my bonus. And so that's actually happening today for companies that have adopted data mesh. I think it's really cool, actually. I'm quite excited about this because I don't see often people linking value of data to the data, the people who are producing the data. So, just a little bit, and I'm only going to talk on one slide on this because this is quite complicated. There are no products that do this today. There are a number of companies who are choosing a number of approaches to solving this problem, but there are no products in the market that really do this. So this is kind of trying to describe all of that I talked about at the beginning, where we have our group up here of domain owners. And when I talk about a domain, some people say to me, oh yeah, but a domain could be like 10 people. It could. We have a customer in the US who is a big bank. They have an anti-money laundering domain. It has 800 staff. So the guy that is in charge of that is like the head of AML for a massive bank. He is the domain owner. He is responsible for anti-money laundering and for fines and regulatory compliance with respect to anti-money laundering. So these could be very senior people in a company. And he probably doesn't go along to the meetings where they say, this is how we're going to think about personal data, but he probably delegates that to someone that he trusts. So those people from maybe, in that case, maybe from anti-money laundering, maybe from fraud, maybe from, I don't know, some other aspect of banks, or financial services, they get together and they define these policies. And we have these kind of global policies, you know, the way we think about customer, the way we define customer, you know, things like GDPR, the right to be forgotten, all that sort of stuff. And then once we've defined these global policies, they're going to be implemented by the domains. And then we have this thing called automation, which basically allows us to check in an automated fashion that those policies have been kind of complied with. And this is kind of that whole picture on one slide. Now I said there aren't any software companies that sell a product for this. What we've seen people do is essentially just have like unit tests. So they will have they will create a data product, it will land some data somewhere, and before they make it available through a catalog, to find it or whatever, then they will literally run some SQL. You could use machine learning, but in most cases, simple SQL that sort of says, do we have a column that looks like address? Yes, we do. Is it masked? Yes, it is. Awesome. Do we have most of the fields having less than 10% missing values or null values? Yes, we do. Okay, so we've passed that test. So that ability to have those tests running, unit tests, when we first create a data product and whenever the data is refreshed, is basically what organizations are doing now that have adopted data mesh, and they're kind of building these themselves. So that's there's a lot in data governance for data mesh, but I'm aware that you guys, it's not the most exciting of subjects. It's just, if you want a deep dive on this, then we definitely can. So I'm going to stop there, and I've got about 2 or 3 minutes. And I haven't talked about Starburst. I'm quite happy not to talk about Starburst, but if any of you want to talk about Starburst, we can talk a little bit about Starburst. But otherwise, questions, I guess. Thoughts? Does anyone care about this? Is anyone here just for the pastries? Yes. We've got someone.
Yeah.
Yes.
I just want to really understand the difference between, let's say, years of use we are doing data governance, data warehouse, data fabric, and self-service analytics and self-service BI.
Yep.
If you bundle all of them, it's actually very similar to data mesh, conceptually.
Yeah. Yeah. I'd argue with you, but let's go with that. Yes.
So what is the key difference? Just
So
this is not a new thing. So
no. It's I guess it's the combination of a number of old things in a new way. So I think the big difference is ownership, right? So you're giving ownership of that process to the domains, right? I think that's the biggest change.
So when you say giving the ownership to domains, you also give ownership of data engineering?
Yep.
So isn't it a bit risky?
Which is the? Oh, it could be. But what's the risk you're thinking of?
That in every business line, you have to hire some data engineers.
Yeah.
So you are actually distributing the central IT or engineering department.
Yes.
Data scientists can be, yes, data citizen on the business side.
Yep.
There's no so much risk.
Yeah.
But putting a data engineer,
Yeah.
making the governance much more difficult. Maybe that's just a question.
So it's a good question. So there's two things that you've kind of mentioned there. One is the fact that you need more people. I can answer that with respect to Starburst. I was speaking to the guys at Zalando recently, and they said the reason they chose Starburst was so they didn't need additional people, right? So there are technology capabilities that you can use that reduce the amount of people that you need, right? So, and there should always be, right? Automation, we should automate things. We should make things easier. That's what technology is for. If it was the other way around, we shouldn't be buying it. And then in terms of governance, I agree, it's harder, but what we have at the moment in terms of governance is typically we have a group of data governance people, and we have business people, and the business people say, I want this, and the governance people go, no. Whereas what we're kind of saying is we're building governance into the process. So we shouldn't have a conversation where someone says no. We should have a conversation where the people in the business go, I would like to do something with this data, and they talk to the domain owner or the governance person in their team and say, can we do this? And the governance person says, no in that way, but what about this? Because I understand what you're trying to do. I understand, let's say it's address data, I understand that for maybe a marketing campaign, you can use this data if someone has checked the box, right? Because I understand the context and what you're trying to do, because I'm in your domain. And I can take that knowledge or that idea or that requirement to the governance board once a month or whatever, and I can say, this is what we're going to do. Can we get agreement across the business? So if you're going to use this data product, maybe you can have access to this, or maybe you can't, depending on security. So I think you are right, there is risks. But I think most of the risks at the moment you can kind of overcome. And what we're kind of doing is we're doing it, governance is really interesting. We're doing it the other way around. Instead of asking someone who doesn't know why or the context of the question, we're talking to someone who understands why we need to do something. And it's more likely that we're going to get a yes, if it's even a limited yes, in a shorter time, because they understand why we want to do it, as opposed to someone who may not. Now, in terms of the other things you mentioned, you talked about data fabric, data warehouse. I'm going to be controversial here. There's no such thing as data fabric. I'll tell you that. And I'll tell you why I can say this 100%, because if you go to Forrester and you look at the data fabric wave, and you look at the definition of data fabric, and then you go to Gartner and you look at the definition of data fabric, and you look at the quadrants, they are completely different. They have completely different definitions. Go Google later on. There is no such thing as data fabric. It's basically a collection of capabilities that people like IBM go, oh, I'll buy this data fabric. What is the first question is, what's a data fabric? And they'll go, oh, it's all these things. But what is a data fabric? Why would I care? So Gartner will talk about automation and machine learning of data management activities. Now, that's cool, but let's think about that for a moment. Let's think about machine learning models that are going to build data marts for marketing or for finance. Right? There's a lot of organizational knowledge that you want to put in those. There are no machine learning models or AI or any of that stuff that can take the information that you've got about your industry, your market, and put them into rules for a piece of data. We just don't have those. That technology is just not there yet. But that's what Gartner kind of proposes. Forrester's a little bit less. They don't talk about machine learning at all, in fact, and their level of automation is much lower. So it's just quite interesting. So I'm going to say there is no such thing as data fabric. There is things like data virtualization and data federation, but they're much less ambitious in what they say they can do. Then the last thing is data warehouses. So we say actually there are 2 or 3 domains where active customer makes sense, but for the other domains, it doesn't make sense. So if I think about, customer's a really good example. If we think about the way that finance thinks about a customer is probably when we raise an invoice. If we think about how logistics views a customer, they're probably interested in where the product or services has to be delivered. If we think about marketing and the way they view a customer, that's not, they haven't actually bought anything yet, potentially. You could say they're a prospect, but they may call them a customer as well. And so now we have 3 different definitions, and it may be that you say, actually, we want a way of bringing these things together, but they all each have their own single source of truth. But they do need to be interoperable. So you may have a lighter rule, which basically says, actually, the customer key is always the same, but the context could be different. So in finance, we are interested in a customer and a name and a billing address. In logistics, we may have a customer name, customer name and an address, which is the shipping address, right? But the key is still the same on both. So you can, I guess it kind of depends on the organization and how you want to deal with this. There's a lot of discussion on this, and the term that is used in data mesh world is polyseme, which is, we like to give names to stuff. But basically, the way I think about it is it a data, like a data mesh entity, or is it a domain entity? And that's kind of the 2 things that I've just tried to describe. So.
Each domain will be managed on governance policies.
Correct.
Also, we still have to manage all the system governance from top of the view of the company. For example, customer side.
Yeah.
For example, 3 domains has own active customer definition, but I would like to put a active customer definition for all of the company, because on the BI system, I have to filter from active customer place, for example. It should be a unique definition. Because of that, we have to put some governance domain for all systems.
Yes. No, you're correct. We don't necessarily have to put it in the system, because remember the data product, right? So one thing that I've seen, and this is kind of slightly off topic, but one thing I've seen is a central data team being kept for enabling domains. So they have a much smaller central data team. And a really simple but concrete example is that that enablement team, data enablement team, let's call them, they create a UDF, a user-defined function. That user-defined function has to be applied to every customer key, right? Now, what that means is that there's some standard code that does whatever it does, some transformation or whatever, that then applies to that particular field in all of my data products, which means that I am guaranteed that I can join 2 data products together where it makes sense to do so, because if you like, the transformation has been applied to both or to all data products in the same way. So there are ways of doing this. I guess data mesh doesn't say you have to do one or the other. It kind of says the federated board of people, the domain owners, can make the decision as to, so for GDPR or PII data, right, you can imagine that at the company level, we want to make sure that we are hiding sensitive data. So that makes sense. But there may be other fields where you say, actually, the way we think about a customer here is different from the way we think about a customer here, and we can have both things at the same time. It's not one or the other. It's kind of, we could say, actually, we always want to hide telephone numbers or credit cards numbers, but we always want to make customer key available. And it might be that actually we want credit card numbers for the finance people. So there are, essentially it's a framework, and then you can put the rules in that make sense for the business and also for the data itself, if that makes sense. Long answer, sorry. This is the official oh crikey, we're over time, so I do apologize. I can talk a little bit about Starburst if anyone's interested, but if you're not and you need to go, then I will not be kind of embarrassed, but it's up to you guys. I'm happy to talk a little bit about Starburst. This wasn't meant to be about Starburst. The reason I was going to talk, the reason I mention this is because before the session, I had at least 2 people come and say, can you tell us a little bit more about Starburst? So I have some slides, But if as I say, if you want to leave, then that's fine. I won't be offended. So, this is your last chance before I jump in. So, all right, these are, I'm not gonna, where am I gonna go? This is all, I may need to get a different slide. Okay, these are weird slides because they're really focused on kind of data mesh, and I don't have the Starburst slide that I wanted. Right, so let me think about Starburst in general. I don't have a good slide for it. This is probably good enough. Right, so Starburst is a technology that's based on a product, an open source piece of software called Trino, which used to be called PrestoSQL. So in about 2011, a company called Facebook used Hadoop. They still use Hadoop today, HDFS at least, for their files. And they wanted to better be able to exploit people. Basically what Facebook wanted to do in 2010. The engines that were available at the time were things like Hive and early versions of Impala. If you are familiar with those engines, they are SQL engines that allow you to run SQL queries on Hadoop data. Quite frankly, they are terrible. So Facebook decided they would build their own. And Mark Zuckerberg went out and found these three guys, very clever folks, and they built this engine. And over the period of from up until about 2017, these three guys were at Facebook and they were building this engine. And this engine, as I say, was called Presto originally. It's now called Trino. The engine itself allowed hundreds and hundreds of users to be able to run queries through tools like Tableau and Power BI against data in HDFS where they had many, many petabytes of data. Right, so I could basically run a query and I could understand how these sorts of people would interact if I was to show them this advert. And I'm running a query across billions and billions of records, and I want that query to run almost instantaneously. So they built this engine that allows you to do that. 2-3 second response times. They left Facebook because they fell out with Mark Zuckerberg. Long story, but anyway, they left and they set up a company called Starburst. And really what Starburst does is it gives you a compute engine. So if we think about a traditional database, we have two parts. We have a compute engine and we have storage. So if you think about Oracle, you put your data into Oracle, you put your data into the Oracle file system inside Oracle, and then you have a query engine, the Oracle query engine that sits on top. When you run a query, it's going to interact with that data. Similarly with Snowflake, you put your data into Snowflake and it lays it out across basically S3 in a particular complicated partitioning, which allows their engine to go very quickly on that data. Starburst is basically an engine, and it's an engine without storage. And so what that means is that you can use whatever storage technologies you want, and you can run queries against this compute engine. So it could be that I have a query that comes in from something like Tableau or Power BI into the query engine, and the query engine might use Oracle, it might use Amazon S3, it might use something like Parquet files in MinIO, it might use Snowflake, or something else, Delta or whatever, as its actual data store, right? So as the actual storage of the data. So it essentially, when you send that query into Starburst, Starburst says, what's the fastest way of changing this query and running this query with using the least amount of work to get the fastest response time. And that may be that the query comes into Starburst, Starburst rejigs the query, sends a bit into Oracle here, sends a bit into Teradata there, a bit into Snowflake or whatever. It might be that it says actually the network connection and the performance of a SQL Server isn't very fast, and it would make more sense for Starburst to stream data out and run it as part, and actually do the processing in Starburst. So Starburst makes all of these decisions in terms of the fastest way to run that query, no matter where your data resides, to give the end, to give the response back to the end user. So it's very much focused on a scenario where you have maybe some data in the cloud, some data on premise, or you have some data on maybe it's stored on S3 or maybe on Hadoop, and you just want fast response times. You don't want your end users to know or care where the data resides. And that's really what Starburst does. And then there's one step beyond, and I wish I had some slides for this, but there's one step beyond, which is where we have a number of customers who are global in nature. In fact, we have a company called Sophia Genetics. This is quite a good example. And Sophia Genetics are a clinical data trial company. So basically they run clinical data trials for new drugs. So someone will go to them and say, we want to run a new trial in people of a new drug to see, you know, if they've got this illness, how, if we give them this drug, how it affects them. And they run these trials in a bunch of different countries, including Turkey. So they run them in Brazil, and they run them in Turkey, they run them in Scandinavia, they've got a bunch of things in America. And these platforms are some are on Hadoop, some are on Oracle, on-premise. Certainly the ones in Turkey, I think, are using SQL Server. Some are using Microsoft Azure, Synapse and whatever in America. And so they have a bunch of people in the Netherlands, where their head office is, who want to run a query that says, I would like to understand how many people have had a bad reaction to this drug who live in a house where there's a cat. Right? And you might go, well, that's a ridiculous thing. Why do we care? And it might be that, you know, the drug or whatever has, you know, maybe the cat breeds out hair and that has an impact on the way the drug works or something, right? So something. The data that is stored about the people on clinical trials is very sensitive, because it's not just address and people, it's all of their medical history. It's all of their environmental data, right? Because you want to isolate and make sure that if they're having an adverse reaction, it's because of the drug and it's not because of something in their environment. So it's really sensitive data. And so what they do is they use Starburst. They have Starburst deployed in every country. They have a Starburst cluster, and they have one in the Netherlands, and they can send a query into the one in the Netherlands, and what happens behind the scenes is they'll send this query to, you know, how many people have had this adverse reaction, live in a house with a cat. That query gets sent to all of those different platforms, and only the aggregate data gets sent back. So let's say it's a count. So let's say we had 2 in Turkey and 5 in America and 3 in Brazil and 2 in, I don't know, in France. Those counts come back nearly immediately to that person in the Netherlands. I've processed all the data in those places, so I've not moved data, I've not broken any privacy laws, I've not broken any sovereignty laws, but I can get that result almost instantaneously in the Netherlands to see how my drug is doing across all those countries. So this is really what Starburst allows you to do. It's able to run queries on data that is in different platforms, in different countries, and be able to give response times to end users very quickly without them knowing or caring kind of about the data. And obviously there's quite a complicated security model that you can put over the top of this to prevent people from doing bad things. So that's kind of where Starburst sort of fits. And if we think about what I said about data mesh, the reason why we talk about data mesh, let me go back, is that if you think about data, you don't buy Starburst and get a data mesh, right? What I think Starburst is good at is it's good at providing some of the capabilities if you want a data mesh. It's good at providing capabilities for other things as well, but I talked about this separation between data and technology. So Starburst provides this, right? I can run queries through SQL, through my BI tools, without knowing or caring any of the technology implications. We have this data as a product thing, which I'll show you a screenshot of in a moment, which is really kind of starts to get towards a data catalog. We have this ability to operate with many things like Hive Metastore and standards for security and standards for catalogs. And then the last thing is we have this ability to call out to third-party platforms to do some of that automation of testing. You wouldn't necessarily do that in Starburst, but we have that ability to call out. And then the last, I'll just show you this. This is a screenshot of Starburst. Now, I would expect 90+% of users of Starburst to not know that they're using Starburst. They will just use their BI tools or even like a Python notebook and you know, connect to Starburst behind the scenes. But their user interface is likely to be a BI tool of some description, except for this particular screen, which is where we have kind of a list of data products. And you can come in here and you can click on them you can find out information about them, etc. And then when you're looking at the data products, you can get connectivity information to that data product, which you can then bring into your BI tool. So your BI tool can then connect to the actual data that lives behind the data product. So I will stop talking there. That's again, apologies, I'm over time. But that's kind of like a 5 or 10 minute description of Starburst. I think Starburst is pretty cool. I've been in this space for a long time, too many years, and I can only work for companies that basically have cool tech, because I'm very honest about their limitations. So the fact that I'm at Starburst means that it must be quite good, otherwise I would tell you that it's rubbish. So I think it's cool. It's not for every customer, it's not for every organization. If you want to put all your data into one place and you're happy with that, then then fill your boots, and Starburst doesn't, it's not necessarily going to help you unless you put all your data into like an object store, and then it's a very fast query engine. So I will stop there, and if there are more questions or more information or whatever that you want to know about Starburst or data mesh, then we can catch up after. I don't know if I've got I'm going to go right back up to that first slide with those links, so that if anyone wants those links on data mesh or whatever, then you can get them easily. But I will stop there, and thank you very much for your attention.